this topic, we have to learn about diffraction. Diffraction is a phenomena observed in the case of waves, and here we need to know the diffraction of light. Diffraction means the bending of light around corners of opaque objects. Opaque objects having the size almost as that of wavelength of light. And wavelength of light, we know it's in the order of angstrom, that is 10 raised to minus 10 meter. And when light meets such very small objects, it will bend around corners, and that's why shadows are having fuzzy ends. Fuzzy end means light falls on these areas also, and that is due to the bending of light, and that phenomena is known as diffraction. And here we need to know about Fresnel's zone concept. And before that, we need to know what is a wavefront. Wavefront is a collection of points having same state of vibration. By same state of vibration, what we mean is, suppose we are having a wave like this, and it's another wave, and here the point is the point at which the displacement is maximum, and here the displacement is maximum, and we say these 2 points are having same state of vibration. Here it is the lowest point, lowest vibration, and here it is also the lowest vibration. That is, these 2 points are having same state of vibration, and the collection of points having same state of vibration is known as wavefront. And if the object is a point object, if the source of light is a point source, the wavefront will be like this, that is spherical. Wavefront will be spherical, and at a particular distance these points represent collection of points having same state of vibration, that is points at same distance, that is points on the sphere with the radius r represents the wavefront, and that's the idea of wavefront. These zones are constructed on the wavefront, and suppose this is the portion of wavefront. This wavefront is from a source, this is a light source, and this is a wavefront at a particular time, that is the light traveled a particular distance during that time, and this is a wavefront. And then the wavefront at the next instant, then it touches the aperture. Aperture means the small gap having dimension or length approximately wavelength of light, and this portion consists of different zones. And if there is a screen here, and there is a point P here, light will be coming from this zone, this zone, this zone, and this zone. That will depend upon the size of the aperture, and the different contribution will add up. Therefore, the total effect at the point P is given by adding the effect from different zones, and that's the idea of zones. Next, we will learn how these zones are constructed. Suppose this is a plane wavefront. Plane wavefront is from an infinite source, that is, if the source is at infinite distance, the wavefront will be plane. If the source is a point source, wavefront will be sphere, and if the source is at infinity, wavefront will be like this, plain wavefront. And if the source is a slit or a wire like source, the wavefront will be cylindrical. And here this is a plain wavefront, that is the wavefront from an infinite source. And zones are drawn based on a particular point P. If we have to find the effect at the point P, join P to the plane wavefront, and the joining point is known as pole O. Let that be O. Then this is the first zone. Again, this circle is a second zone, and then third one, etc. And it is drawn with wavefront. Let this be equal to B, and this distance will be B plus lambda. Again, join this to P, and this distance will be B plus lambda by 2, B plus lambda by 2 plus lambda by 2, that is B plus lambda, and to the next B plus lambda by 2, etc. That is, the difference is in terms of lambda by 2. Lambda by 2 corresponds to a phase pi. ഒരു വേവിൻ്റെ ടോട്ടൽ വേവ് ലെങ്ത് ലാംഡ ആണെങ്കിൽ, ലാംഡ ഇസ് എ വേവ് ലെങ്ത്, ടോട്ടൽ ഫേസ് എന്ന് പറയുന്നത് 360 ഡിഗ്രി ഓർ 2 പൈ. ആൻഡ് 2 പൈ ഫേസ് കറസ്പോണ്ട്സ് ടു ലാംഡ പാത്ത്. 2 പൈ ഫേസ് ഡിഫറൻസ് ഉണ്ടെങ്കിൽ അതിൻ്റെ അർത്ഥം ലാംഡ പാത്ത് ഡിഫറൻസ് ഉണ്ട്. ഇറ്റ് ഈസ് എ half of 2 pi, that is pi is a phase difference if lambda by 2 is a path difference. Here we know the path difference. Path difference means the additional distance the point has to cover. ഈ രണ്ട് പോയിൻറ്റിൻ്റെയും പാത്ത് ഡിഫറൻസ് എന്ന് പറഞ്ഞാൽ തൊട്ട് മുകളിലത്തെ പോയിൻ്റ് എന്ന് വരുന്നതിന് കുറച്ചുകൂടെ ഡിസ്റ്റൻസ് ട്രാവൽ ചെയ്യണം. അതെത്രയാണ് അഡീഷണൽ ഡിസ്റ്റൻസ്? ബിക്കോസ് ദ ഡിസ്റ്റൻസ് ഈസ് ബി പ്ലസ് ലാംഡ ബൈ 2. പി പോയിൻറ്റിൽ നിന്നാണ് വരുന്നതെങ്കിൽ ബി ഡിസ്റ്റൻസ് ട്രാവൽ ചെയ്താൽ മതി പിയിലേക്ക് എത്താൻ. ഈ അഡീഷണൽ ഡിസ്റ്റൻസിനെയാണ് path difference എന്ന് പറയുന്നത്. path difference between this point and this point. Here the path difference is lambda by 2, that is phase difference is pi. Pi means out of phase. അതായത് പൈ ഫേസ് ഡിഫറൻസ് ഉണ്ടെന്നുണ്ടെങ്കിൽ, ഇതാണ് ഒരു വേവിൻ്റെ പോർഷൻ, പൈ ഫേസ് ഡിഫറൻസ് ഉണ്ടെങ്കിൽ this will be the form of another wave. If these two waves are having a phase difference pi, ഇത് മാക്സിമം വരുന്ന പോയിന്റിൽ അടുത്ത വേവിൻ്റെ മിനിമം ആയിരിക്കും, അതുപോലെ മിനിമം വരുന്ന പോയിന്റിൽ അടുത്ത വേവിൻ്റെ മാക്സിമം ആയിരിക്കും. ഇതാണ് പൈ ബൈ 2 ഫേസ് ഡിഫറൻസ് കൊണ്ട് ഉദ്ദേശിക്കുന്നത്. That is, each zones is having a phase difference of pi. Then we need to calculate the radius here, and this is a right triangle. Let R1 be this radius of the first zone. This is a right triangle, and from this is a base, this is a altitude, and this is a hypotenuse. And we know hypotenuse square is equal to base square plus R1 square. That is, R1 is root of b plus lambda by 2 the whole square minus b square. Root of b plus lambda by 2 the whole square minus b square, that is the radius of first zone R1. A plus b the whole square is a square plus 2ab. 2ab is 2b into lambda by 2, that is b lambda plus lambda by 2 the whole square, lambda square by 4 minus b square. B square gets cancelled, and lambda is a very small value, that is of angstrom range. That means lambda square is even small, that is we can neglect the term with lambda square, and this is root of b lambda, and this is the radius of first zone, and area of first zone is pi r1 square, that is pi b lambda, that's the area of first zone. Again we need to calculate the radius of second zone. So these are the zone. It is constructed based on the point P. This is O, and we have did the first zone. Again we need to calculate the radius of second zone, and this is the radius of second zone. Let this be R2, and this distance is B plus lambda by 2 plus lambda by 2, that is B plus lambda. That means R2 square is root of, and this distance is B plus lambda the whole square minus B square, that is root of B square plus 2B lambda plus lambda square minus B square. B square gets cancelled, lambda square we can neglect lambda square, and that's it, that is 2B lambda. Again area is pi r2 square, that is the area of second zone is this area, that is area minus the area of first zone. This is the area between these two circles, that is the area of second zone, that is area is pi r2 square minus pi r1 square, that is area of second zone, and pi r2 square is pi into 2b lambda minus pi b lambda, that is pi b lambda. That's the area of second zone. Area of second zone means the area between this circle and the first circle and the second circle. So we have to subtract the total area, subtract the area of first zone from the total area, that is pi r2 square minus area of first zone pi r1 square, and what we get is pi b lambda. And from this r1 is root of b lambda, r2 is root of 2b lambda, and area of first zone is pi b lambda, and area of second zone is pi b lambda itself, because area of the area we should minus the area within the first zone. And in general, area of each zone is equal, and that is equal to pi b lambda, and radius for first zone root of b lambda, second zone root of 2b lambda, and for nth zone the radius is nb lambda. And this is a Fresnel's zone concept.